The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is how Exalogic be a logical choice for your business applications. And our guest speaker today is Ramakrishna Kommuri. He is the Exalogic System Administrator at Heuristic Informatics Private Limited. Ramakrishna Kommuri completed Master of Computer Application and having vast experience as an IT professional and working as Certified Exalogic Administrator in Heuristic Informatics Private Limited. Expertise in designing, implementation and deployment of applications on engineered systems and troubleshooting. Having expertise knowledge in designing and implementation on multiple products like database, PeopleSoft. So, without further delay, I introduce you all to our guest speaker. Over to you, Ramakrishna.
So, thank you, Aradhana. Hi, good afternoon, one and all. Today the presentation is all about how Exalogic be a logical choice for your business applications, and the 45 minutes walkthrough session will be discussing about regarding the IT managers and for the IT architects who are planning to deploy their Exalogic missions into their own organizations, and the session will help the system admins, system architects who need to become a certified Exalogic as administrators, and for the newbies who are planning to work on these Exalogic applications. So basically, no more than ever, it's been a past since from past in the IT. The most valuable currency in the IT organization in the world is the information, right? The customers access the information via application. No, the customer satisfaction depends upon the application responsiveness as well. No, the application responsiveness depends upon the application where it got deployed, in the sense the application where it got hosted. So if the platform where the application got deployed has the discrete components, has the individual components, like the network, like the storage, like switches, so these all integration depends upon the application responsiveness. Therefore, managing all these discrete components and in terms of scalability, in terms of reliability, so it faces the heavy challenges in upcoming world. So therefore, let's put a dot to all our hurdles of discrete components, that is the individual components of application where it got deployed. Now, let's give the rise to innovation, transformation, and the performance, and finally achieving the success by engineered systems. So these are engineered system. We are having a family of engineering products. There's Exalogic is one of the part of engineered systems, and Exalogic is basically designed for enterprise Java-based applications, exclusively for middleware applications. That's Oracle Fusion middleware applications as well. And Oracle Exalogic is an integrated hardware and software. It's been designed to provide a complete platform for wide range application types and widely varied application workloads. So Exalogic enables customers to develop their customized environment to support all consolidated end-to-end applications. So this Exalogic is having the greatest features, which is providing the highest performance. Now, how can we achieve the highest performance, highest reliability, and the scalability? So in the 45 minutes through session, we will be, the session will help us to get the overview of the system components and how we are achieving the performance by the Elastic Cloud. So this is the program agenda. So we are going to discuss about the Exalogic components, that is the compute nodes, and the Exabus, network, and storage. So these are all the components that are being integrated within the Exalogic. So we'll be going to see all these components and how flexible towards the implementation and the maintenance of Elastic Cloud. And the next one, how to achieve the breakthrough on application performance and scalability with Elastic Cloud. How do we achieve the application performance with the help of this Elastic Cloud? What integration techniques has been enabled only on the Exalogic for particular applications? So we are going to see that part, and how to reduce IT cost, complexity, and the risk through integrated platform. So by integrating all these components, how can we reduce the IT cost and how can we reduce the complexity as well? So we'll be going to see, this is the program agenda which we are going to discuss. So this is the present organization, what enterprise IT business demands. So the IT needs, we need to provide the quality of service within the time with the less cost. So this is the formula what the Oracle has approached, what the Oracle has proved, and has been developed the engineered systems to provide the quality of service within the time, within the less responsive time, with the less cost, with the less maintenance and the complexity. So how can we achieve this formula? This formula can be achieved by Exalogic, and that is the Elastic Cloud. Normally, if I want to deploy one application, therefore I'm reaching different vendors to support and host my application. If an application is hosted on it's a PeopleSoft, so therefore I need to approach for Oracle for the application, and I need to reach a different vendor for the operating system. I need to reach different vendor for HP, that who is providing the servers, and for the networking I need to reach a different vendor Cisco, and for storage I need to reach different vendor NetApp. So therefore I am reaching for to support single application. I am reaching different vendors to integrate. I'm reaching different vendors. So therefore, to integrate all these vendors and to achieve the highest performance, which is a most complex situation. Now, how can we put dot to all these integration techniques that by the customization? Yes, the Oracle has come up with a solution that they are providing the integration of all these components, the storage, the network, the compute nodes, and the networking. So they are integrating all these components and they're providing in a single box. That is, this box is called as a Exalogic stack. And either it can be called as a stack or it can be called as a rack. And by integrating all these components into a single rack, so they have tuned it and they have optimized the techniques. So within the integration, they have developed a lot of customization techniques which gives the maximum performance. Now, how can I reduce my complexity? Yes, if my application is on different components, therefore the managing of each and every component within the data center, which leads to the data center cost. So therefore, the horizontal space within the data center is been growing, and the cost for the IT data center cost is growing more. So therefore, how can I reduce my data center cost? Yes, it can be reduced by the horizontal space can be reduced by keeping all the components in a vertical fashion within the Exalogic box by integrating each and everything. So, which doesn't occupy more than 5 square feet. So almost like by this I have reduced my IT data center cost and the complexity and achieving what we require. So this is the problem what we faced earlier, and the Oracle has came up with a solution that they have given with engineered systems. So we are having multiple engineered systems. That is, we are having Exadata for the database, and for middleware applications we are having Exalogic. And if we integrate Exalogic and Exadata, that is called a supercluster. So in the same way, we are having the standalone ZFS servers, that is known as ZFS3, that is called as the external standalone ZFS servers. So these are all the engineered systems that are available from the Oracle. So let's see in the hardware of each and every component, what type of hardware component and what optimization techniques do we have in this particular Elastic Cloud suite. Okay, from the year of 2010, we have the different versions released by Oracle. The first version released by Oracle is X22, and later on they came up with the next version available from the Oracle is X32, and the next version is X42. So the present right now in the market from the Oracle, we are having X42 is the newest version, and which is which can be available in the two configurations, high capacity and the high performance. So let's see what all the components do we have in Elastic Cloud. Yes, this is the total Elastic Cloud, and if you open the front cabinet door, so the internal view looks like this. So these are all the components within the single Elastic stack. In this total stack, all the components are integrated. Now let's see into each and every component. So this is the computer tier. So computer tier in the sense means it's a compute node, which is called as a compute node. Compute node in the sense means like standalone physical server, which is equivalent to. So we are having two sockets, and for each compute node is having two Intel Xenon Ivy Bridge processors. Each processor is having 12 cores. So therefore, 12 into 2, almost like 24 core processors per each and every physical compute node. And 512 GB of RAM, which can be expandable up to 512 GB from 256 GB of RAM. And we are having 800 GB of SSD node, which is called SSD in the sense solid state disk, which is not equivalent to normal disk. So the SSD disk is different, entirely different from normal HDD disk. It doesn't have any moving part internally. So therefore the performance from the disk level will be more. And we are having two SSD disks for each and every compute node, which are configured in a mirrored fashion to give the high availability in the failure of one disk. And we are having 720 cores in a full rack. So in a full rack, we are having total 30 compute nodes, which will give the 24 into 30, which will give to 720 cores in a full stack. And pre-cabling for full rack is being done by Oracle itself. We need not to install, we need not to configure each and everything. So by default, Oracle will configure by this itself and will provide to the customer. And these compute nodes will support either Oracle Linux or Oracle Solaris. So no other operating system can be installed on these unit systems, only Oracle Linux or Oracle Solaris. And the next one is the IO fabric. That is the internal IO fabric, which is called as a network. So this network, if we can see closely observe it, say we are having these are the switches. What we are seeing is called as a gateway switches. Totally I am having 6 gateway switches, 4 switches called as a InfiniBand gateway switches, and one is called as management switch, and other one is called as spine switch. So each and every gateway switch is having its own importance and its own prioritization. And each and every switch is came up with a 40 Gbps IOPS per second. So the switches are configured in such a way that it gives a maximum performance, and it has a speed of 40 Gbps per second. Now how it is achieving 40 Gbps speed? Therefore, the gateway switches are achieving the 40 Gbps per speed with the help of HCA ports. So these are HCA in the sense means host channel adapters. So with the help of this host channel adapters, the switches are achieving the maximum performance with the help of these gateway switches. So each and every compute node and each and every component within the total entire Exalogic has 2 host channel adapter ports. Therefore, each and every port is being configured in an active-passive configuration to achieve the highest performance. So the network, the next part is the storage here. So within the single stack, we are having the storage. So this storage is similar to NAS and SAN, but which is having the highest features, but maintaining this storage will be very easier if you compare with NAS or SAN. And the replication of this storage is very easier when compared with other vendors. So I am having the capacity of 80 TB SAS disks and 6.4 TB of read cache and 292 GB of write cache. Then what is meant by this 80 TB of SAS disks? Yes. So this storage is having the disk shelf, which can be configured in a mirrored fashion. So therefore, even if one disk got failed, it can be replaced. So this is called as a disk shelf, which is having 6 rows and 4 columns equal to 24 disks. So manually we are having 24 disks which are configured in a mirrored fashion, and this disk shelf is being survived by 2 compute nodes. The upper part is called as the compute nodes, which are called as storage heads, and either can be called as controllers. So the total disk has been surviving with the help of these disk heads. So the next one is the fault tolerance. Now each and every component within the total elastic cloud has been configured in a mirrored fashion. So if one component gets failed, the other component will come into existence and survive the total stack. Now I am having dual power distribution units. So the power, I am having the two power distribution units which are configured in the rear part of the elastic cloud. Even if one power distribution gets failed, the stack will get survived with the other power distribution unit. If both they get failed, therefore it will be the loss. Now, in the same way, for each and every component, I am having power supplies. So it's like the SMPS in each and every standalone desktop. We are having two power supplies in each and every component. Here, coming to the component is called as the compute nodes, gateway switches, storage system, management switch, compute nodes, and InfiniBand spine switch. So these are all the components. Each and every component is having two power supplies. Even if one power supply got failed, the particular component will get survived with the other. So I am having N+1 fan cooling fan strategy. So therefore, that to reduce the temperature that's been generating from each and every component, so we are having the cooling fan strategy which cools the processors and total entire component. And we are having dual HCA ports, as I told you earlier. So each and every component is having two HCA ports, 1+1, and redundant storage heads. So we are having two redundant storage heads here, which will be working as an active, passive, and which are configured in the clustered mode. And all are SSD disk and HDD RAID. So the disk shelf are having 4 SSD disks, and rest of the remaining are HDD disks. Yes. So these are the different flavors that are available from the Oracle. That is 8th rack, quarter rack, half rack, full rack. Yes. So the difference between all these racks, in the sense, the number of components in the 8th rack will be very less, and the number of components in the quarter rack will be increased from the 8th rack. Yes. Now let us see what are the components in the 8th rack. Yes, I am having only 4 compute nodes in the 8th rack and 96 cores totally, and 1 TB of RAM and 80 TB of ZFS storage. So this is the storage expansion and the available configurations in the 8th rack. And in the quarter rack, I am having 8 compute nodes, which is equivalent to 192 cores, and the storage is having the capacity of 2 TB of RAM and 80 TB of storage. And in the half rack, it is having 16 compute nodes, which is equivalent to 384 cores, and the storage is having 40 TB of RAM and 80 TB of storage. In the same way, full rack is having 30 nodes, which is equivalent to 720 cores and 7.5 TB of storage RAM and 80 TB storage capacity. So these are the different flavors that are available from Oracle that the organization can purchase as per the needs and as per their needs. And once we purchase the 8th rack, we can convert the 8th rack into either quarter, half, or full rack by adding the number of components to the existing configuration. For example, if I purchase 8th rack, therefore if my business grows, therefore I can add 4 more compute nodes to make it as a quarter rack. And still if my business is growing, so therefore I can add some more compute nodes which can make it as a half rack to make the business, to reach the business demands. So therefore I can increase the rack configurations and I can come up with a full rack. So if it is a full rack, therefore I cannot add any more components to the existing configuration. No, I can integrate, we can integrate the Exalogic stacks with one another and engineering systems with one another up to 8 Exalogic systems. Yes, we can integrate up to 8 Exalogic systems. That is called as a multi-rack. So the maximum is 8 and the minimum is 1. Yes, then. So that is the hardware configuration. And then how can I configure the total Elastic Cloud? So, configuration of Elastic Cloud is in a very easy way. The installation, the configuration, the Oracle has implemented by single command. We need not to configure each and every component, as we have the number of components in the total Elastic Cloud. By seeing all those components, there is no need to get frightened. So all these components can be installed with a single command and with a single script. We need to fire the single script which will take over everything and configure all the components. Now, what script do we need to fire? Yes. So we are having Exalogic OC.sh script which we need to execute. So before filling this script, we are having 30 compute nodes. Out of 30 compute nodes, we need to make one of the compute node as a master, and we need to move all the configurations files to that particular compute node, and we need to execute that particular script. Now, before executing this script, we need to fill one of the configuration files that is given by Oracle, which will be same across all configurations, whether it is a half, full, quarter, and el_configuration.ods file which we need to fill. So this file we need to fill with the domain name, country, time zone, and at least each required IP address for ILOM. So it is called as Etho0, Net0, Net1, or ILOM. So we need to give the subnet IP address, and we need to specify each IP address for a bond 1. So bond 1 is which is used for client traffic, and need to specify at least one IP address for it, and at least one of each optional IP address of bond 0. So the bond 0 is already been configured by Oracle. We need not to configure bond 0 manually. By default, by the system itself, we will get the bond 0 itself. We need not to configure it, and we need to specify the NTP server IP address, and we need to specify the name server IP address. Now, what is meant by this name server, which is used for NFS protocols and NFS versions? And we need to specify at least one search domain and default gateway IP address. So once we fill this file and we move after filling this file, we have to move to the specified location where it is a master node is been existing and which we have specified as a master node, and we need to give Exalogic deploy_configuration file and Exalogic_factory.configuration file. Now, so once we execute the script, so Exalogic_factory.configuration file will get invoked, and it will do all the pre-verification tasks before the configuration. So it will do all the pre-verification tasks. So once the pre-verification task done by the factory configuration file, so therefore it will go ahead for the deployment of all these configurations. So once the deployment is done, you will get a message that all the configurations are being completed. In the meanwhile, when the configuration is happening, it will show the progress, like how many scripts are in the pending and what are all the configurations have been completed and in which level the configurations have been completed. It will be showing the progress when the script is being executed. So once the script is being executed, so therefore we can check the configuration whether it's been done successfully or not. Yes, it can be pre-verified and it can be verified with the help of administrative tools. So these are the tools that are available from Oracle for Elastic Cloud, that is Topology Verifier, InfiniCheck, Hardware and Firmware Profiler, Software Profiler, Boot Manager. Yes, let's come up with the Topology Verifier. Yes, so this is the command line utility which will use to check whether the InfiniBand has been established and has been configured in the proper fashion or not. If it is not configured properly, therefore it will throw you the alert these particular configurations have not been configured. And the next one is the InfiniCheck, which is a command line tool that verifies whether all the ports of components have been configured or not, whether it is up and running, does any port is having any issues. So it will filter all those sort of issues and it will pop up the message if it have any issue. So, and the next one is the hardware and the firmware profiler. It will ensure that whether the firmware for each and every hardware is up to level of mark or not. If there are any firmware issues, so therefore it will trigger those issues at the time when the script got executed. And the next one is a software profiler, which will check whether all the RPMs across all the compute nodes has been installed properly or not. If the RPMs has not been installed and if it is not equal to across all the compute nodes, so therefore it will pop up the message and it will trigger that these RPMs need to be installed on one of the compute node and these RPMs need to be installed on the gateway switches. So like this, in this fashion, the software profiler will check and pop up the message. And the next one is the boot manager here. Now instead of after all the configuration, suppose if there is a case that I need to reboot or re-image the software or the OS in a single compute node. Therefore, I can use the boot manager, that is with the help of pre-boot execution environment called as PXE. With the help of this utility, I can boot the image of OS in the single compute node. So these are all the tools that are available from Oracle for Elastic Cloud, which can be verified and checked for each and every component which is in the correct fashion or not. And the first one is a distributed command line interface, which is used for if you need to fire. I am having 30 compute nodes, that is equal to 30 standalone servers. Now, if I need the output of one command across all 30 compute nodes, which will be a hectic task, and firing a single command across all compute nodes by doing the SSH will be a critical task. So therefore, the Oracle has came up with a solution giving that DCLI command line interface. So this command line utility will execute the command across all the compute nodes, and it will display the output from all the compute nodes. So therefore, if you need to fire any command across all the compute nodes, we can use the distributed command line interface, which is having the different syntax and which will work in a different environment. Okay. So these are the administrative tools that are available from Oracle. The next one is the architecture. Yes. What architecture does Exalogic have? How it's been configured and how it's been integrated here. We are having complete nodes, that is servers, which is equivalent to, and the storage we are having, and we are having the network. Now, how we are integrating all these components? By integrating all these components, how we are achieving the performance? So that is the main one, which we are breaking the application performance. So the first of all here, I'm going to discuss about the network part. Here I'm having the three networks: InfiniBand network, client network, and the management network. The client network, which is called as the Ethernet over InfiniBand, which needs to be configured by us in the ODS file, that is called as bond1, what is specified as IP address. And for this client network, this client network is used for outside traffic, whatever the traffic that is coming from outside of the data center. So that traffic will be come from the client network. And the client network, if you can see, closely observe the blue lines over here, where the application users have been interacting with the gateway switches. So these are called as a client, the client network, where it is coming with the outside traffic is coming, and all the monitoring agents like Oracle Enterprise Manager, Policy, Ops Center, all monitoring agents, not all, some of the monitoring agents have been configured on this client network, and the speed of this client network will be 10 Gbps. And coming to the management network, yes. So the management network, if you can see the below part, is the management switch. The management network is based upon the management switch. Yes, the management switch, which is used to connect all the components of the Elastic Cloud. So if you can closely observe the red lines which are indicated in the arrow mark, so these are called as management network. So this management network is integrated with each and every component within the Elastic Cloud. And the speed of this management network is 1 GB per second. And the ILOM has been running on this particular management network, and we have been using this management net for other administrative tasks as well. And we are having the next network is the InfiniBand network, which is called as a IP over InfiniBand, and the speed of InfiniBand network is 40 Gbps per second, which is used for the communication between the compute nodes and the storage. Yes, the compute nodes and the storage has been configured with the help of this InfiniBand network with a speed of 40 Gbps per second. Yes. We need not to specify any IP address, we need not to configure any of the InfiniBand network manually. The Oracle by itself, they will configure the InfiniBand network, and which is called as a private network, and they will provide to the customer. And the next one is the storage appliances. So this is part of the network part. And coming to the storage part, here I am having 2 storage nodes and a disk shelf, as I told you. And these storage heads are interconnected with the cluster on hardware, and which are working in an active passive configuration to service the total disk shelf. And the next one is the spine switch. The spine switch, which is used to interconnect Exalogic to Exalogic, or either Exalogic to the Exadata, where the database has been residing. So this is how the spine switch will be useful. And coming to the next one is the OTD. Yes, the OTD is specific to only to Elastic Cloud. We don't have OTD to any other component. We don't have OTD for any other EBU system. The OTD is specifically and exclusive only for Elastic Cloud, that is Exalogic. Now, this OTD is a fast, reliable, and scalable layer 7 software load balancer that you can deploy as the reliable entry point for TCP, HTTP, and HTTPS traffic for application and web servers in our network. So therefore, whatever the traffic that is coming into the outside traffic, so the outside traffic will come to the traffic directory. From there, the traffic has been diverted to all the compute nodes, whatever it has to go. It has been designed to go. So this is how the traffic directory has been working, and which is a physical load balancing. It's called the physical load balancing, this one. And this is what the Exalogic architecture, which is integrating each and every component with the help of architecture and the traffic directory. And the next one is the Exabus. This is the IO fabric. No. Now, how we are integrating all these components? Yes, we are integrating all these components with the help of this IO fabric. Yes, this is the architectural feature of Elastic Cloud. This IO fabric that is integrating all the components of Elastic Cloud, which provides the terms of reliability, scalability, and the performance. So, with the help of this IO fabric only, we are achieving the words of scalability, performance, and reliability. This IO fabric is called as the Exabus. Nothing but this IO fabric is called as the Exabus, and this Exabus is based upon the QDR InfiniBand fabric. Exabus relates on InfiniBand fabric and has all the device drivers, software drivers, and InfiniBand drivers, and the kernel drivers as well in each and every component. So this is how it has all the drivers and its unique software and the firmware, and it has the Exabus RDMA based API efficiency, and it has the kernel level drivers. So the Exabus, which is unique to Exalogic, gives the extreme performance for Elastic Cloud, and the IO system within the Elastic Cloud is not in the normal fashion. The IO operations that are performed in the Elastic Cloud are different from the standalone. Yes, how is the different? Yes, normally for the standalone, for each and every IO, there will be the intervention of CPU. Yes, but within the Elastic Cloud, there won't be any intervention of CPU. The CPU will be offloaded for each and every IO that will be happening in the Elastic Cloud. So this is where the Elastic Cloud is giving the maximum performance at the network level. So the performance, achieving the performance at each and every level has been distinct, and it is having the combination of network stack optimization. The protocols what it is being using, yes, it's a different from the standalone protocols what it's been used. It's been using native C++ and Java APIs, and with the help of SDP protocol, and it's been bypassing the kernel bypass operations with the help of RDMA, which is called as a remote direct memory access, and the next one is the hypervisor bypass, SIOV, and on-chip network virtualization. So this is how I'm achieving the performance with the help of these protocols and with the help of these RDMA concepts, which is bypassing the kernel level applications. And the Exabus software, which is called as the Elastic Cloud software, the present version is almost like 2.0 in the X4 2. This Exabus, we need not to configure anything. This Exabus is configured and is being provided by Oracle at the time of installation and the configuration itself. So if you can see how the latency and high bandwidth communication. Yes. Now for the applications, for the middleware applications, how the protocols has been working. Yes, it's been working with the IP over InfiniBand protocols and SDP protocols and native IP. Yes, it's using the kernel bypass applications, which is known as the remote direct memory access semantics, which will redirect and can access the data from other virtual machine and from other compute node. And this is the standalone, in the standalone server, this is what the architecture, what we are using for the network virtualization. whatever the application that needs to be communicated with other application, therefore the object will get copied from application to application buffer, from application to TCP/IP, from IP to kernel. So therefore the single object is being getting copied to each and every logical layer within the within the compute node. So therefore the amount of time I'm spending for the copies of the object is 20%, and the 40% I'm wasting my time for the transport for processing, and 40% for kernel context switches. So this is how I'm wasting my time for the standalone IO hardware. Now, if I come to the Elastic Cloud, now how the transfer rate and how do I achieve the transfer rate and how do I achieve the minimum latency and maximum throughput. So these examples, with the help of these examples, so this is what the integration has been happening. So I need not to copy to the logical layers between the application. I need not to copy. So automatically the application can directly access the object of other application object. So this is how the zero buffer copy and direct memory access with the help of kernel bypass drivers, which is known as RDMA. And the throughput has been increased to 4x and the latency has been decreased to 6x. So this is how, these are the valid points where the Elastic Cloud has came into the pictures and it's been surviving in the world. So this is a normal diagram which is representing the standard IO hardware, and the diagram which is right side is which is showing the application for examples how it's been intercommunicated. Now let's go with the storage architecture. As we have seen up to now, the network architecture and Exalogic architecture and the compute node architecture, all the stuff. And let's go with the storage architecture, the last one. Here the architecture for the storage, here what we are seeing is a disk shelf, the below one. So these disk shelves which are having the 6 rows and 4 columns, which is equal to 6 into 4, 24 shelves. So out of each and in each and every shelf we are having one SSD disk and HDD disk, either SSD or HDD. Now, so I'm having total 24 disks. Out of 24 disks, 2 will be acting as a spare, and out of 2, that is 22 disks. In the 22 disks, the 4 disks will be allocated for the SSDs, and the remaining is the 18 disks. So yes, the remaining 18 disks are configured in a mirrored fashion. Even if one disk got failed, the availability will be more. And I am having the 2 storage heads which are called as the controllers. Within each and every storage head, we are having the ARC, which is called as DRAM, dynamic RAM, and we are having the L2 ARC, and we are having a read SSDs, which is at the capacity of 292 GB of write cache and 6.4 TB of read cache. So in each and every read operation, what is meant by then read cache and write cache? Yes. Each storage node that is called as the storage head, which together act as a read cache in response to each and every read request. Therefore, this read cache will store whatever the data that has been retrieving by the user. So instead of pulling the data every time from the disk, therefore it will store the data in the read cache. So therefore, like when the next time the user is filing the same object, when the user is required the same object, therefore instead of pulling the data from the disk, it will store the data in the read SSDs. In the same way, it will write the data to the write SSDs synchronously. So in response to write, so each and every write operation has been performed to these write SSDs. Later, in the asynchronous fashion, the data will be written to the normal disk. So this is what the architecture of the ZFS. And this is standard. If you see the standalone, the difference between the standalone and the traditional architecture for the ZFS appliance, we are having the ARC, L2 ARC, and the disk storage pool. And this is the traditional storage system, NVRAM and the disk. So if I come to the ZFS appliance, so whatever the data I am storing in the RAM, so it comes under the ARC, adaptive replacement cache. And whatever the data that needs to be stored in the RAM, if the RAM is not capable of holding that particular object in the RAM ARC, therefore it will transfer that object to the L2 ARC. So therefore the object will be sustained and will be persistently available in the L2 ARC. This L2 ARC has been configured from write SSDs. So therefore, whenever a user is performing a read operation, it will check whether the object is available in the ARC. Yes, it is not available. Therefore, it will go for the L2 ARC. If the object is not available in the L2 arc, therefore goes to the normal storage pool, and it will fetch the object and it will throw to the user. So this is how the architecture has been happening within the ZFS. And for the total pool configuration, this is the profile configuration. What we select the profile for the number of 18 disks what we have remaining. So for this remaining 18 disks, we will create the profile. So for this profile is specifying the profile for the 18 disk is nothing but specifying the right configuration. So at the OS level, we are specifying the right configuration for the storage level. So we can select the right configuration, either double parity, mirrored, stripe, triple mirror, and triple parity and white stripe. Now let me give the example of mirrored. Suppose if I select the mirrored, so therefore all the disks are configured in a mirrored fashion. Even if one disk gets failed, other will be available, and the availability of disk will be more, and the performance will be more, and the capacity of storing the data will decrease. So here for 18 disks, I can store only up to 9.85 TB only, not more than that. So this is how I am decreasing my performance. Suppose if I am selecting the stripe concept, so therefore there won't be any mirroring. Even if the disk got lost, therefore the availability of data will be very less, and the performance will be more, and the capacity is getting increased with the 21.5 T. And if I want to use the storage pool, therefore I need to create the projects and the shares. Project is nothing but the logical group of shares, and share is nothing but the file system, which is equivalent to the file system. We need to create the shares, and we need to specify the properties to the share, and therefore we need to mount the share to the existing compute node. And we will be configuring the standalone ZFS servers as well. And we have the capacity of 292 GB of write cache and the 4 TB of read cache as well. And here we are having the next slide, we are having the failback. As I told you, like two compute nodes will be working as an active passive configuration. Now, so the blue symbol, the green symbol which are representing in the left hand side, so this is called storage node 1, and the right hand side is known as the storage node 2. And the green symbol which blinking over there represents is the active node, and the right hand symbol which is showing the blue mark represents is a passive node. Now at any point of time, we can make the active and passive, active as a passive and passive as a active by clicking on failback option. If you click on this failback option, therefore the roles of the storage nodes will be get diverted. Now the time taken for these two storage nodes will depend upon the grace period. We call it as a grace period. By default, the minimum Oracle is giving the 60 seconds to change. So whenever failover happens, whatever the shares that has been mounted on the compute nodes, it will be unavailable, and the application will be not be in access at that particular point of time, which is a 60 seconds, which won't be more than 90 seconds. So which is which can be ignorable. And if you need to analyze the statistics of the storage, therefore we can select the details analytics, which can be used to do the statistics of each and every component and each and every CPU utilization. So if you click on this add statistics, therefore it will show you the groups. We have the different classes. In each and every class, we are having different components. Like in the cache class, if you want to see the arc access or L2 arc statistics or L2 arc IO statistics, so therefore I can see and I can view about each and every statistics by selecting with the help of details analytics. So within the storage itself, I can view the statistics. Suppose in the compute node, if I need to have the if I need to find the statistics, therefore I can use the top command, something like that. So in the same fashion, in the storage appliance, if I need to find the statistics, so therefore I can use the statistics from dtrace analytics. With the help of this dtrace analytics, we can even schedule the statistics for each and for a period of time. So the below graph what you are showing, I have taken the statistics for NFS 3 version 3 operations, and it's been representing. Yes. Now what about the backup that I am taking? Then what about the backup in Exalogic, Elastic Cloud? Yes. We can move the backup to either external ZFS appliance with the help of snapshot or clones, or either I can move the backups to the tape libraries with the help of Oracle Media Server backups. So either of the case can be implemented as per organization needs and their criteria. And if it is a ZFS storage appliance, the bandwidth I can use is the 10 GB, or either I can use the InfiniBand network, which is a 40 GB per second. It depends upon the organization needs and the availability. And if I need to replicate the data from storage to external storage, therefore I will use the snapshot and the clones. So the snapshot and the clones which can be replicated from one appliance to the other appliance. So this is how I can back up my whatever the data that is being presenting in Elastic Cloud. So up to now we have seen the architectures of each and everything and optimization techniques within established at the storage level, at the network level, and at the hardware level. Let's see the optimizations at applications level here. Now, WebLogic, we are having whatever the application that supports either Tuxedo, WebLogic, or Coherence, whichever the application that supports these three softwares. So therefore, it will achieve the highest performance as per Oracle. Yes, if suppose PeopleSoft will support Tuxedo, PeopleSoft will support WebLogic. In the same fashion, eBusiness Suite will support its requirement. So each and every application, if it supports the software components of Oracle, Tuxedo, or Coherence or WebLogic, it achieves the highest performance. If I am using WebLogic, therefore I should use the JVM as per requirement. So if I am using the Oracle operating system as a Linux, therefore I need to use the JRocket. If I am using the Solaris, I have to use the hotspot as my JVM, Java virtual machine. And I can specify the Java memory heap from 1 GB to the maximum of 4 GB, where the session replications work will effectively. And for WebLogic, intentionally for WebLogic, we have the highest optimizations feature that's been enabled within the WebLogic software admin console itself. So once you go to the domain configurations general tab, we have the option enable Exalogic optimization. So once you click on this optimization tab, so all the optimization techniques that have been enabled for WebLogic will get triggered and it will get executed in a fashion to achieve the performance at software level. And for WebLogic, we can enable the HTTP protocol, which will be helpful at the network level, what I told you earlier. Like we are using the HTTP protocol for the session replication as well. So this is how we can achieve the highest performance at each and every level. So it's not like achieving the performance not at a single level here. It's been integrated to achieve at each and every level. And as we are having the different ERPs, now let me tell you one ERP, that is the PeopleSoft. And the PeopleSoft is having 4-tier architecture that is equal to 3-tier architecture normally. Here I am including the database server as a 4th tier, which is having the application server and the database server, and the application server which depends upon the Tuxedo, and the web server which depends upon the WebLogic. So this is how I am having my PeopleSoft architecture has been designed to use Tuxedo as my application and WebLogic as PAs. So therefore, whenever it's been using, it can achieve the highest optimization with the help of these components. So this is the PeopleSoft architecture, that is the compute node, storage, and the networking part. Here, whatever the requests that are coming to the web cluster, it will go to the web cluster. These can be the compute nodes. So here I am having the application servers, which have been hosted on different compute nodes, and across the database server, and the application developer will be integrating with the application servers. He will connect to the application servers to the application designer to design with their applications with the help of this people code. So whenever the web cluster has been integrating with the application server, so therefore it will use the Jolt handlers and the Jolt listeners, which will be using internally to connect the web server with the application server. So this is how the architecture, normal architecture. Now, if I want to implement this the basic architecture into the Elastic Cloud, so therefore what I will use the web cluster. Web clusters will be deployed on 2 compute nodes, and application servers will be deployed on 2 compute nodes, and batch servers will be hosted on 2 compute nodes. So therefore, even if one compute node gets failed, the other compute node will be available for the survival of the application. So this is how I am achieving the performance. Now coming to the batch server, which is used for scheduling the jobs. So this batch server will be used, which will be running at the database end to execute the jobs. So therefore, it will execute the jobs in a high fashion with the help of 40 Gbps InfiniBand fabric. So this fabric is helping us to achieve the highest performance for executing the PeopleSoft jobs. And once the job is succeeded, so therefore the reports for the particular job will get posted successfully in the specified location. And this is the test case. We can specify two PeopleSoft domains for each and every compute node, and 48 app server process for each and every app domain. And we can give the recycle count to 0, and we can give the log frames as a 2, and we can give the jolt handle set in the PS app server configuration file from 150 to 170, and we can specify the cache populate for all 48 processors, which is around of 1.2 GB cache. So this is how I can specify the parameters for the PeopleSoft application server end for Exalogic. So these optimizations only work for Elastic Cloud, not for any other server. And the same way for PeopleSoft web server, I need to specify the Java heap memory size, and even I can enable the huge pages. So these are all the things. If we take the test case, the optimizations that we can achieve for Elastic Cloud and for other applications, like for other ERPs. So this is the rate of graph that's been provided by Oracle in the recently current past. So this is the one for Tuxedo 11G. The response time is almost has been reduced, and the response time for SOA is been reduced to 58 microseconds, and for ADF 11G and for UCM throughput has been increased ultimately. So this is how the graph showing the performance wise for each and every application, which shows that the response time is less and the throughput is good and the latency is very less. Yes. Then how can I monitor my total Elastic Cloud? Yes, I can monitor my total Elastic Clouds as I am having number of components. Yes. Then how can I monitor each and individual component? It's very tough to monitor each and individual component. So therefore, we are having monitoring agents which will be pointing, which will be keep an eye for each and every second, which will be monitoring total Elastic Cloud. I'm having operational ops center, which is called as EMOC, and enterprise manager policy, and the ILOM management, and the platinum agent SR. So the platinum agent SR will be installed by Oracle, and they will take care of everything. And ILOM management, which is configured, it has a service processor. So the ILOM management is a different one, which is configured on the management switch. So it is called as an agentless monitoring, which is used to monitor each and every component within the Elastic Cloud. And the configuration of this ILOM management has been configured by Oracle itself. We need not to configure anything. And each and every component has a hardware and a software service processor exclusively for ILOM management, which will be working for each and every component. So therefore, whenever the components get failed, even if I need to power off, even if I need to reboot, or even if I need to shut down total Exalogic stack. So therefore, from ILOM, I can log into that particular compute node and I can shut down total compute node. So this is how the ILOM is helping us. And even if there are any disk failure, or even in the case of hardware failure, this ILOM will trigger an alert that will trigger an ASR to check with the Oracle. So, and we are having the operational policy, which is known as the EMOC. This is one of the agents that has been monitoring. So this is automatic op center is automated in such a fashion that once you configure, discover that particular Exalogic or Elastic Cloud or engineering system in this op center. So once you configure this one, so automatically whatever the components that comes under within the single Elastic Cloud will automatically detected. Suppose if I configure a single asset, the single asset in the sense, if I configure single Elastic Cloud, now what are all the components that are comes under this single Elastic Cloud will be configured automatically. So we need not to configure each and everything manually. So Op Center is designed in such a fashion, it's been intelligent in such a fashion that it can provision automatically in each and every component, and it will update us, and it will monitor each and every component. So, and if there are any patches that need to be patched, if there is any requirement that the software or the firmware is not in a proper fashion, so therefore it will trigger an alert to the user that this particular component is not reaching to the standards of Oracle. So please check with this Oracle system. So therefore, with the help of this monitoring alert, so therefore the user need not to keep continuously an eye on the system. So therefore, whenever there is an alert, so it will automatically trigger an mail, or either it can send the mail to the mobile as per configuration. So this is how the op-centered policy is having the highest features, and it is only exclusively only for Elastic Cloud, not for any of other business system. It's exclusive for Elastic Cloud. And the next one is the Exalogic report, the last one, which will generate the report of total health check. So we can run either on a monthly basis, either on periodical basis for any pre or post maintenance activities, which will give the overall health score. The health score of total Elastic Cloud is here it is showing 92. The recommendation is about we should get at least 95 score out of 100. So this score specifies, resembles. So the health of your Elastic Cloud is very good. So how can I specify that? How can I do a benchmark that my Elastic Cloud is running in the proper fashion and is having all the availabilities to run properly? So this health score will help us to detect that the system is in the health condition. And so it detects problem as per Oracle Metallic document note 144492226.1. We can check how to execute this Exalogic health check report. And suppose if there are any views, if there is anything that has been failed, now let us suppose that these are the warnings that have been given by for the health check report. If there is any message, and that message, for every message it will show the status whether it is a fail or a warning. So let us take that IP configuration for ethos 0 and bond 0 are not configured correctly. Now this, if we need to check this particular error, so therefore you can click on this particular view option. So once you click on this option, therefore it will show what action and what recommendation need to be taken care for that particular warning to upgrade my health check report. So therefore it will show the links. So these are all the links you can check on the meta link that will give the some more idea and clarity what needs to be configured, and it will show where we need to keep the attention. Do we need to keep the attention on all the compute nodes or storage or switches? Yes, it will show on which component the attention needs to be take place. So here it's specifying that compute node 1. Yes, we need to take the attention on only compute node 1. So this is how I can check, I can verify the health check of total Elastic Cloud with the help of this Exalogic report given by Oracle. So thank you. Any questions?
Thanks for the insightful presentation, Ramakrishna. Let's quickly take up the questions now. I would request you to read out the questions and their answers so that all our users may listen to your insights. I request all attendees to start posting their questions.
The first question I got that is this related to Hadoop? No, this is the application server where you can deploy all the Fusion middleware applications. If it comes under the Fusion middleware application, then it can be hosted on Elastic Cloud. So whatever the versions that are certified to run either on Linux or Solaris, so those certified Fusion middleware applications can be executed and can be developed on Elastic Cloud.
Due to time constraint, I have to request you to take the unanswered questions offline, which I will share with you through email. If you would like to sum up the session for today, you can do it now, Ramakrishna.
Okay. I got only one question right now up to now, and if there are any questions, they can send us a mail for me. will be available on the link.
Any closing line from your end?
No, I can able to give only one question so far.
So due to time constraint, it's already 4 o'clock. So I would have to request you to take the unanswered question. I'm not assigning you more questions offline, which I will share with you through email. So right now, if you like to sum up the session, you can do it now. So any closing lines that you would like to give to the audience?
Yes. So this is the total Elastic Cloud, which is providing the maximum performance for each and every applications, which is exclusively developed by Oracle and giving the maximum performance. Yes, this session, I think this session is helpful for all the invitees who joined. So therefore we can end up the session.
I'm really thankful to our guest speaker today for conducting this wonderful webinar. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of the webinar will be available on techgig.com by tomorrow. Thank you all for joining us today. Thank you, Ramakrishna, for taking the time out and having us. I hope you have a great evening ahead.
Thank you.